region whose area is given by this definite integral. Integral negative pi by 3 to pi by 3 2 minus secant x dx. You see, can you read it like this? Integral a to b f of x minus g of x dx. So you can interpret this as the area enclosed by the graphs of f of x equal to 2. What is f of x equal to 2? Y equal to 2. And g of x equal to secant x. Yes, this is actually the area enclosed by the graphs of f of x equal to 2 and g of x equal to secant x from x equal to negative pi by 3 to pi by 3. Alright, can you draw these graphs? So, I can write this as integral negative pi by 3 to pi by 3 2 dx, that is integral a to b of f of x dx minus integral a to b of g of x dx. This integral is the same as this. Now, f of x equal to 2 or y equal to 2. So here I have the graph of f of x equal to 2. Now, g of x equal to secant x. How do you draw the graph of secant x? Secant x is 1 over cos x. So you can enter in the calculator y2 equal to cos x. And of course, set your scale negative pi by 2 to pi by 2 so that you have the given limits there. So here we have the graph of secant x, g of x equal to secant x. And what is the area that we are interested in? The area enclosed by f of x equal to 2 and g of x equal to secant x. The definite integral represents the area enclosed, and this is the area. That's right. So you must learn how to interpret a definite integral or how to interpret a given area. Alright, let's do this one now. Sketch the region bounded by the graphs of f of x equal to 3 minus 2x minus x squared and g of x equal to 0 and find the area of this region. Well, first of all, f of x is this function. G of x equal to 0 means the x-axis. Now, in order to find this area, we need to know the boundaries. X equal to a to x equal to b. How do you find the boundaries? The boundaries are obtained by setting f of x equal to g of x, or set f of x equal to 0 and solve for x. So this is our f of x. And look at the graph of that. I'm sure you can draw that graph and get this result. So this is our f of x. G of x equal to 0 is the x-axis. There you have. And so what we are looking for is the area enclosed by f of x with g of x from x equal to a to x equal to b. We need to find a and b. Find the points of intersection. How? Set f of x equal to g of x. There you go. Can you solve this quadratic equation? Well, you can factor it. Try this. It will be x plus 3 times x minus 1 equal to 0. That will give you x equal to negative 3 and x equal to 1. So, one point of intersection corresponds to x equal to negative 3 and the other point corresponds to x equal to 1. Therefore, we now shade the area between x equal to negative 3 and x equal to 1. The area enclosed by f of x with the x-axis. And write down the definite integral. The area enclosed by f of x and g of x is integral a to b, integral -3 to 1, f of x minus g of x dx. Now what is our f of x? F of x is 3 minus 2x minus x squared. Our g of x is 0. So we don't need to worry about g of x. It is 0. So we have integral -3 to 1, 3 minus 2x minus x squared dx. Can you do this integration? Integral 3 dx is 3x. Is that right? Integral minus 2x dx is minus 2 times x squared over 2. The 2's will cancel. So that would be minus x squared. Integral minus x squared dx will be minus x cubed over 3. Is that right? So that will be 3x minus x squared minus x cubed over 3 from x equal to -3 to x equal to 1. And now replace x by 1 for the upper limit here. Then subtract, replace x by -3. So that would be 3 times 1 minus 1 squared minus 1 cubed over 3. That takes care of the upper limit. Minus 3 times -3 minus -3 squared minus -3 to the power of 3 over 3. That is replacing x by the lower limit, -3. Alright, let's simplify that. That will be 3 minus 1 minus 1/3 minus, that is that negative sign. 3 times -3 is -9. -3 squared is +9. With this negative sign would be -9. And -3 cubed is -27. Divided by 3 is -9. With this negative sign would be +9. And that makes no problem there. You can see here that will be 3 minus 1 is 2. 2 minus 1/3 plus 9. Is that right? This 9, -9 will go, minus -9 is +9. And that will be 32 over 3 is this area enclosed by the graphs of f of x and g of x. Well, you must actually practice this. Now, watching the video will not really teach you. You learn it by actually doing it on your own. So close the video now or pause the video and try this on your own. Now, the area enclosed by the graphs of f of x and g of x from x equal to a and x equal to b is, what is that? Integral a to b, upper function minus the lower function. In other words, f of x and g of x are functions of x. Remember, a function of x is generally called y equal to. Is that right? Y equal to x squared minus 3. Y equal to sine x. So you go in the vertical direction. Now, suppose you have functions of y. Now, if functions of x are called y equal to, then functions of y will be called x equal to. Suppose you have x equal to 4y minus 3, x equal to sine y. They are functions of y. If functions of x are upper function and lower function, because the functions of x are expressed in terms of y along the vertical axis, then functions of y will be along the horizontal. Then instead of the upper and lower, you have the right function and the left function. Is that right? Yes. So the area enclosed by the graph of f of y and g of y, two functions of y, from y equal to c to y equal to d, will be integral c to d, the right function minus the left function. The function on the right minus the function on the left. Okay, now let's have a look at that. Suppose this is a function f of y, and the red line is a function g of y. Look at the area enclosed by the graph of that. Now, these two functions meet at y equal to c and y equal to d. So what does the enclosed area gives you? The enclosed area is this, the area enclosed by f of y with g of y from y equal to c to y equal to d is integral c to d f of y minus g of y, the right function minus the left function. Well, let's practice this. Sketch the region bounded by